Deep inside every atom, there is a world in constant motion. At the center, a dense and powerful nucleus. Surrounding it, incredibly tiny particles moving with extraordinary behavior. These particles are called electrons. An electron is a fundamental particle. It carries a negative electric charge, and it plays a crucial role in electricity, chemistry, and modern technology. Show classical orbit animation. For a long time, scientists imagined electrons orbiting the nucleus, like planets around a sundae. But reality is far more fascinating. Transition into quantum cloud visualization. In the quantum world, an electron does not travel in a neat circular path. Instead, it behaves like a cloud of probability. We cannot pinpoint its exact position. We can only calculate the likelihood of finding it in a certain region of space. Show continuous smooth motion. So why doesn't an electron ever completely stop? Because the laws of quantum mechanics do not allow it. Due to its wave-like nature and the uncertainty principle, a perfectly motionless electron simply cannot exist. Visualize electric attraction. At the same time, the attraction between the negatively charged electron and the positively charged nucleus creates a dynamic balance. Motion shifts to electrons flowing through a wire. And when electrons move through a conductor, that motion becomes electric current. The electricity powering our lights, our computers, and the digital world around us is driven by these tiny particles. Return to atom view. A small motion at an invisible scale creates enormous effects in our visible world. Electrons may be tiny, but their impact shapes the structure of reality itself.